Welcome to Elektor Engineering Insights, the show that puts your engineering challenges to the industry's experts. I am your host, Stuart Cording. There are just 2 weeks left before Embedded World opens its doors in Nuremberg, Germany, after a 2-year COVID-imposed hiatus, and there is a tangible pent-up excitement about visiting the show and seeing each other again in person once more. So to warm everybody up for the trade fair, this month we're focusing on embedded systems and Internet of Things, or IoT technology. My panel of experts this month includes Barath Koppa from Tasking, Ulderico Arciadiaco from Sfera Labs, and Fabio Tranchitella from Mender.io. Welcome to the show, gentlemen. I'm going to start and move over to Barath and bring you in briefly. There we go. Hi there, Barath. How are you? Let me just switch on your mic there for you. Oh, there we go. You need to turn on your mic yourself. There we go.
Oh, sorry.
No problem. How are you doing?
Fine, thank you. How are you today?
I'm great, thanks. So tell us briefly about what Tasking does. You're the company that you work for.
Yeah, so Tasking, we supply safe and cyber-secure software, embedded software development tools. And our customers are using these tools to develop safety applications in the automotive field. And we have compilers for Infineon Oryx and Klaviyo 2. And apart from that, we also have tools that can help our customers generate optimum code, high-performance code with a smaller footprint, software footprint. And our focus in the last years has mainly been in the safety field. So our intention or our idea is to automate as many things as possible in the safety qualification process, that the customers don't have to do manual work, or that reduces the time to market for our customers.
And that's a great point, because we're going to be coming back to you shortly to talk a little bit more about safety in software development for automotive applications. So thank you very much. We'll be back with you shortly. And I'd just also like to say hello to Ulderico from Sfera Labs. Hi. Tell us a little bit more about Sfera Labs, the company you represent.
Yeah. Sfera Labs, at Sfera Labs, we develop hardware mostly based on open platforms or widely well-known platforms, particularly Raspberry Pi, Arduino stuff. And what we do is basically what we say is that we dress them up to go to work.
Right.
So basically we take a Raspberry Pi and surround it with the electronics needed to be able to safely and reliably run that platform in a typical industrial environment. That's what we do.
Super. Sounds very exciting. We'll be back to that again shortly. And finally, I'm just going to bring in Fabio into the mix as well. Hi, Fabio. Tell me a little bit more about Mender.io.
Hi, Stuart. Thank you for hosting me. So Mender is an open source end-to-end solution to implement over-the-air updates for embedded devices. So using Mender, you can update all the software running on your IoT devices, ranging from full system updates, so updating the operating system of your device, which means that we integrate with the bootloader and provide a brick-free experience to update your devices, as well as application updates. So you can update the software that you implement and want to deliver to your devices. On top of that, Mender can help our customers and users providing device management and monitoring solutions.
Excellent. And those are all very exciting, interesting topics, because I think keeping your firmware up to date in IoT type and Industry 4.0 applications can be quite challenging. So I'm looking forward to coming back to you in the show. Thank you very much.
Thank you.
So I'm very excited this month as well, because we are supported in this particular episode of the show by our sponsor, SparkFun. Since 2003, SparkFun has been helping turn ideas into reality with its open source products and documentation. This makes emerging technology easier to use and shortens the road to a finished product. To simplify your next project, why not take a look at SparkFun's prototyping system, MicroMod? It's a solderless modular interface ecosystem that uses the M.2 standard to mix and match your choice of boards. So all you need to do is choose your combination. So on with the show. Of all of the different branches of electronics, embedded is definitely my favourite topic. So naturally I have plenty of questions for my guests. However, this show is for the engineers out there struggling to solve problems. Regardless of where you're watching, post your questions and comments during the show using the chat function on YouTube and LinkedIn, or via Twitter using the hashtag ElektorEI. And we'll do our best to get answers during the show or guide you to some resources that might help. So I'm going to go back now to Barath from Tasking. I'm going to bring you into the stream again. Welcome back.
Thank you.
Great to have you on the show. So tell me, what's your position at Tasking? What's your job?
I'm a technical sales engineer at Tasking, and I've been at Tasking for the past 2 years. It's an excellent company which brings out creativity in the employees. And I've been given a freedom to develop a lot of applications, and I'm happy to show you something today that would be really interesting from the automotive perspective, of course.
Super. And is that the sort of the market that your customers typically work in automotive? And if so, what sort of applications are you helping your customers with on a daily basis?
Most of our customers are in the automotive field. So all the tier ones and the OEMs who are basically using Infineon Oryx are coming to us. And we have one of the best compilers in the market. And that's the reason, they keep coming back to us, licensing our compilers. And so.
Super. Now, automotive is also an industry that's close to my heart. I've spent a lot of time visiting the big tier ones and the other players as well that feed into that industry. And automotive is also an industry that has very strict safety demands. If you're in the business, it will be termed ASIL, automotive safety integrity levels. Could you just explain to our audience a little bit about the difference between QM, which is quality managed, and the different ASIL levels, and what sort of applications in the vehicle would expect to fulfill which type of levels?
Yeah. You're absolutely right in the sense that you mentioned that there's strict safety requirements in the automotive field. But when you look at the safety specification in general, these safety concerns not only automotive but also industrial and agricultural machinery and so on. So there are like a bunch of fields for which safety is interesting. Also, for example, railways. So we also have some customers coming from industry and railways, who come to us and ask about safety. But let's focus now on automotive. The applications which were looked at from a perspective 10 years ago, it's not the same anymore. They are being looked at from a different perspective. If you look at, for example, a seat heating unit in a vehicle, so 10 years ago you would have said, okay, it's not that important, it's not that safety critical. But right now, when you look at our customers who are trying to design such heating systems and so on, they say that it needs to be safety qualified. It's a safety critical system. Imagine a case that you're driving your vehicle and your seat overheats, and let's say you have a burn on your back, right? I mean, this is something critical, and the worst that could happen is you lose focus and you can have an accident. So
yes,
this is the perspective that we are looking at since a few years, since the beginning of automotive safety. And I can show you a small slide.
Yeah, I'll just bring those up for you. There we go.
Yeah, sure. So if you look at the ISO 26262 specification that talks about safety, talks about QM. And there are also QM is quality managed, which basically means that an application is not safety critical. But you could also have applications ranging from ASIL, so the automotive safety integrity level, A till D, with D being the most safety critical system. If you look at an example of electric power steering system, that's an ASIL D, or a braking system, or an airbag deployment system, that could be an ASIL D system, because if there's a malfunctioning ECU in a vehicle, then you could have an accident. It could be dangerous to the passengers.
So And that's one of the interesting things about the automotive industry. Like you said, it continues to develop, it continues to change in its approach. And what I've seen, at least, is that we're seeing a move to taking the electronic control units in the vehicle, and rather than building one ECU for a particular function, what automotive suppliers are looking at is integrating several functions into a single ECU. But if I've got one ECU with an application on it that's ASIL D, and I've got another application which is maybe only needs to be approved to ASIL B, does that mean that everything on the ECU has to fulfill the ASIL D safety level, or is there, because obviously that's more work, isn't it?
That's an excellent question. So, I mean, when you look at an application and you say it's a safety critical application, and you target it to be an ASIL C or an ASIL D, then the specification states that the application or the software has to be developed as per ASIL D. But again, it gives you some concession. It says if you don't want to develop it as an ASIL D, what you could do is decompose the ASIL D requirements into, let's say, an ASIL A and an C, or you could have, let's say, two ASIL Bs. Partitions or software partitions running inside, running on a microcontroller. So this is what I try to point out. So I mean, if you look at, this is just an example. So if you look at an Infineon Oryx, let's say a Core 0 could run a QM and an ASIL D. This is allowed. Or you could split up an application into two ASIL Bs. But the most important thing is that you have to then make sure that these two partitions or sections are not interfering with each other. So you have to make them independent of each other and make sure there is no freedom from interference related errors. When you look at the AutoSAR specification, then it talks about memory, execution, and timing and exchange of information related freedom from interferences. So this is where you have to focus on when you create partitions in a system.
So this freedom from interference, what that means then is that the individual applications that are running on the ECU, maybe these individual functionalities that have been assigned a specific ASIL safety level, somehow we need to prove not only that the functionality is, that the function works as expected, for example, a window lifter, that the window lifter fulfills all of its functionality, but we also need to prove that these different ASIL levels of the application don't interfere with each other, and that the ASIL B part of the code doesn't cause the ASIL D part of the code to work incorrectly. Is that right?
Yes, you're right. So I mean, when you look at a system, let's say you want to have as you brought out, a window lifter, a window system. So let's say you have a control unit which is controlling the windows of a vehicle, and you have certain components, let's say a component 1 and a 2, which are basically trying to modify or to change the position of the windows. And let's say you want to communicate the status of the window position to another ECU inside your vehicle. And let's say you have a component 3 which is running on the same ECU, but maybe uses a FlexRay or a CAN interface to transmit the status of the window to another ECU. What you could do is have the complete system developed as per ASIL B, or an ASIL level. And I say an ASIL level because this could also turn out dangerous. So let's say you have your hand jammed inside, between in a mirror, in a window, that could be dangerous, right? I mean, so you may have to when you design a system, you may think, okay, the window lifter module could be an ASIL B, for example, and the communication between two ECUs, at least for this module, may not be that safety critical, and you can have it as a QM, for example. And then what you could do is have an ASIL partition which runs two components of a certain ASIL level, and have a QM partition which is basically, in this example, transmitting some window status. But make sure that you have a clear restricted read and write access in memory, and let's say you are restricting uninterrupted function call. So what I mean by this is that a QM a function which is residing in a QM partition should not accidentally invoke a function which is there in an ASIL partition, or try to modify a register or a variable which is assigned at a higher ASIL level.
So how is the automotive software developer doing that today? How are they checking to see if there is any cross interaction, and that there is no interference between these partitioned elements?
So there are some microcontrollers available in the market which do not have something called as a memory protection unit, an MPU. But when you look at the safety specification, it clearly mentions that if you are developing ASIL C or an ASIL D application, you have to then use a memory protection unit on the chip. And you basically turn on the memory protection unit, make some configurations, and this particular hardware unit will raise exceptions when there are unintended memory accesses. The problem with that method, though, is that we have developers developing applications. They turn on the MPU, and all of a sudden they see like a lot of exceptions. And what do they have to do is debug the application for this particular exception. I would just say optimistically 20 minutes. And then they have to build their software, and it could be different for a different system. Let's say you're talking about a very complicated ECU, then may take you like 3 hours to build the complete software. And then you have to continue this process for each and every exception that you get, right? So this could be time consuming. And in the end, you have done all the work. You have just made sure that your MPU is working properly, but there is no, so to say, a report that says that you have tested all possible scenarios that could lead to an MPU exception.
Okay.
And yeah.
So I was going to ask then, so I understand then that you've developed a tool within tasking called the safety checker. Explain a little bit more about safety checker and how that integrates into the software development process.
Yeah. So the safety checker is based out of a compiler technology. And what we try to do is with the safety checker is to bring up, the safety checker is a static analysis tool, and that can help you detect, let's say, 90% of the freedom from interference errors related to memory accesses and unintended function calls inside a system. And the tool is developed as per ASPICE level 2. And how it works is that you feed all the C and .h files in your project to the safety checker, along with a safety access file, which lists out configurations of the customers. You can then point out and say, okay, so an address area is an ASIL B or a QM, or you can say this function is basically ASIL D, and it cannot be invoked by another QM function and so on. So this is what you mentioned in the SAF file. And after you run a build with the safety checker, so it passes through all the C and H files and basically creates an error file, which lists out all the freedom from interference violations in your code, in your project. And then what you could do is, try to fix all these memory violations at a time, and then run a build, and then this can save you like a lot of time, lot of time which you spend on debugging.
And how much effort is required by the software developer, or how much do they need to change in the way they develop code? Do they need to sort of rename variables as they're defining them, or any other sort of changes to the development process?
Yeah. So basically, this tool is microcontroller and compiler independent. And the advantage of using this tool is that you make all your configurations in the configuration file of the safety checker. So basically, your source code remains unaltered. So you don't have to change anything. Let's say you have a situation where you make architectural changes at a time where when you are close to SOP. And then you cannot, and then you want to save time in testing your software. So this is a best use case for the safety checker. So then what you will have to do is just make changes in the safety access file, and then the safety checker then lists out all the violations, and then maybe you can fix it, and then you have a clean system.
Super. Now, I think one thing that maybe those who aren't involved in the development of automotive applications won't be aware of is that sort of BMW contract out the development of an ECU maybe to a supplier like Continental, and then Continental won't build all of the software to go into the ECU. They'll subcontract out certain parts of it to other people as well. And in that process, the software that gets integrated together in the final stages of the product aren't all delivered in source code, are they? Some of them are delivered as binary files. So how can Software Checker be used to sort of accommodate binary files that are being integrated into an application?
Yeah. So this is a very good example because I recently had a customer ask me the same. So they were also getting software from multiple suppliers, not just 3, but a lot of suppliers. And some of them were just giving them binary files because it was their IP and they did not want to share it with the customer. They don't want to share the C and H files with the customer. So what we could do with the safety checker is you could ask your maybe a supplier to run the safety checker on his source code. And the safety checker could then generate a VDA file. So this is an internal safety checker internal file, which just has information about the interfaces. So what sort of a function do you have in the code, and what are the parameters that you are passing to the functions, and so on. So this information is contained in the VDA file. So when you share this with your customer, so he could then use this VDA and all his C and H files with the proper configuration, and then maybe create one final report for his project that talks about the freedom from interference violations. And you could also have a look at the call graphs that is reported in the report file of the safety checker.
Super. So I'm just going to take a break here from my questions and see what's going on amongst our audience. I've got Jack here. I'm not quite sure where Jack is based, but Jack is asking, is anyone attending Embedded World this year? Which is an excellent question. I understand that Tasking has got a booth at Embedded World in 2 weeks' time. Is that correct?
Yes. So we will be at Embedded World. And you could visit us, and we have a set of really experienced and good engineers, who can help you with the questions that you have in your project related to compiler and static analysis tools, a static analysis like MISRA, CertC, or freedom from interference, for example. And yeah, I mean, we look forward to see you at Embedded World.
And I guess you'll be there as well?
Yeah, I'm there as well, yes.
Excellent, super. So we'll get to meet you in person.
Yes.
And another question is, obviously, automotive electronics and automotive generally is an industry which is maybe from the outside a bit difficult to understand how everything works. What was your career path into automotive electronics?
So I started out after graduating from university in India. I started working for Robert Bosch, and where I developed embedded software for engine management, ECU. And then after studying at Fachhochschule Rosenheim, I started working at BMW as a contractor. So I was more into developing bootloaders, ECU reprogramming stuff. And then I was at Düsseldorf working with Renesas Electronics, and now at Tasking. Okay. And a company to work for. I mean, it's fun.
Excellent. That's great to hear. I'm really pleased about that. So if you'd like to visit and chat with Barath directly about the safety checker or anything to do with the development of software for the automotive industry, Tasking will be in Hall 4 in booth number 255. So feel free to drop in and have a chat with him there. So that's the end of our audience questions for now. Barath, thanks ever so much. Stay on the line because we're going to move over to Ulderico Arciadiaco from Sfera Labs now.
Sure.
So there we go. Hi.
There you go. Hi.
Good to have you back again. I'm just going to tidy up the screen there so as we can see your face properly. So you gave us a great introduction to Sfera Labs and the products and solutions. What's your particular role within the organization?
Yeah, I'm the head of hardware engineering. So I take care of the hardware design of our product ranges. And basically, I'm the one concerned with the component shortages situation and all the impact that it has on the electronics industry at large.
Yeah.
But yeah, besides this, I take care of the general design of the hardware architecture of our products, and then we have a team doing the, let's say, lower level development of everything.
Super. I'm going to come back to you on the point of chip shortages and hardware shortages towards the end of our session. But I'd like to start by talking to you about the industrial automation space that you're in. Now, As somebody who sort of takes an interest in what goes on in the industry, there are plenty of PLC providers. There's big names like Siemens and Honeywell, Schneider and Delta. There's a wealth of I/O equipment, sensors, actuators, motor inverters. What is it that's attracting your customers to Sfera Labs?
Yeah. Well, first of all, I don't think that there is, let's say, one single best solution for everything. So
Correct, yeah.
I'm 100% sure that there are areas where, let's say, a more traditional PLC might be more suitable for a certain task. But at the same time, there are other areas, or maybe just a different mindset from the engineers who prefer to work on different environments, on slightly different environments. So we're not pretending to say that our products are better than PLCs. It's far from that. It's just a slightly different approach. What customers want and why they seek this kind of approach, actually. I've seen that in many cases they very simply want to work with hardware where they can have, let's say, a deeper look inside. They can, they don't want to see the hardware product as a black box, whether it's just the hardware or the software stack around that, but they want to see, to become more intimate with the product. And definitely, if the core of your product is a Raspberry Pi, this kind of, let's say, intimacy is already built in a sense.
Yeah, exactly.
And that's one. The fact that the core platform of the product is a popular platform has a lot of other, of course, implications. But let's say, particularly talking about hardware, one is that it might be much easier to port an application, maybe from a prototype developed on a Raspberry Pi or an Arduino, to an industrial product based on Raspberry Pi or Arduino, rather than building everything from scratch. You already have that. We had customers coming to us saying, well, we have developed this prototype application, and in the end, the prototype is just what we need to do. It works, an application. Okay. Now the only missing link is the hardware. We cannot just run it on a Raspberry Pi powered by a USB phone charger in the end. Okay. And this is one important, let's say, path toward our products. Another thing is, I'm saying that against my own, let's say, interest, is that if you have a platform like this at the core, you are, let's say, less into vendor lock-in. I mean,
exactly.
yes, maybe one day you may decide that rather than using one of our products, you may use something else similarly built from someone else, and in that case, the migration path would be much easier. And finally, I could say that customization is another thing. We are, let's say, large enough to be able to develop industrial hardware for industrial application, whatever. But at the same time, we are the right size that we can follow our OEM customers into their own customization paths. They ask us to develop, let's say, for example, stripped down versions of our hardware or beefed up versions of our hardware. So starting from our standard products, you go either way to have a product that more, let's say, tightly matches your requirements. And these probably are things that you cannot do on a Siemens S7 or something. That's
exactly, yeah.
In that case.
Yeah. So as you said, you've based your product portfolio and services and development services that you provide on Arduino and Raspberry Pi, and our audience will obviously know those as just boards.
Yeah.
You can't, obviously you can wrap that in a box, but that doesn't make it robust enough for industrial. And we know that, for example, Arduino, they're based on AVR processors that's sold by Microchip. There are industrial versions, and industrial versions of microcontrollers are specified to operate at higher temperatures and maybe under more challenging conditions electrically than maybe the commercial versions of those parts. So what do you need to do, or what needs to be done in order to make Arduino and Raspberry Pi suitable for the strenuous environment of an industrial application?
Yeah, well, first of all, I must say that, let's say, when we say industrial application, in a sense, the industrial word is kind of a buzzword. It's not a technical specification XYZ that states exactly what needs to be done. So we let's say loosely talk about industrial application because we are let's say consider a general framework where you need reliability, robustness, whether it's electrical or again in terms of reliability. But of course there are like specific application environments within different industries where there are, let's say, requirements, and maybe, of course, we do not fit all the possible industrial environments in the world. But just to give you an idea, I mean, actually, Arduino and Raspberry, I mean, are fine, provided that you don't have some, let's say, totally extraordinary constraints or requirements, are fine for industrial applications if they are, again, wrapped into something that creates like the interfaces, the support electronics, like power supply stages, reliability features, like, I don't know, external watchdogs, redundant storage, for example, and other stuff. Well, to give you an idea, I have one. This is basically the inner part of Iono Pi. This is one of I/O modules. This is based on the Raspberry Pi compute module. And just to give you an idea, I think this is better than talking. This is the Raspberry Pi, the compute module.
Yeah.
This is the module. Now, the component ratio between these two is huge. I mean, this thing has about 1,000 parts. Wow. Okay, overall, it's 3 boards packed with components on both sides each board. Okay, this one is this. Okay, it's a beautiful piece of hardware, but you know, this is basically the hardware you need to, let's say, dress up the Raspberry Pi to get into an industrial environment to do some specific things. I think this gives an idea. Let's say more than other more, let's say, abstract considerations.
Exactly.
Another thing that came to my mind when you asked this is it is not a similar question that we asked ourselves. I'm old enough to remember that when, like, the PC was initially introduced in the IT industry, and the mainframe guys said, "Oh my God, we cannot have these things into the office because they're not reliable or whatever." And after that, when Linux came on the software side, I was working in a very large multinational IT consultancy firm back then, and these people from Digital, Hewlett-Packard, and so IBM, they were screaming at us because we were trying to push Linux into the IT environment. And they were saying it's not okay, it's not supported, it's not this, it's not that. And you know, I don't have to tell you the rest of the story.
Of course, yeah, exactly, yeah.
So
you're absolutely right. So that's a very good point, because that is another concern even today. I think people are worried about open source software. Is the support there? We rely with Arduino, for example, as Raspberry Pi users on the community and forums to help us. But another sort of really important aspect of the type of products that you're putting into the market is security. All of these devices are networked, they're linked together, they're potentially not just networked within a closed environment, they need to also speak to the outside world and share their data via dashboards. So that's a challenge that everybody's faced with, the security of these IoT applications. What do you offer with Sfera Labs and the hardware that you provide in terms of keeping the system secure?
Yeah. Well, in terms of hardware, the most direct answer is that basically we decided to have a secure element chip on most of our products. Right. So we use the ATEX 608 from Microchip. That's a support chip that provides encryption functions, secure storage, keys generation, and stuff like that. Right. And that's one thing directly addressing the let's say the security issue in hardware. The other thing, in my opinion, is more general. In the end, what we develop is basically I/O modules, edge servers, sensors, this kind of stuff. And a lot of concern, I hear people saying, well, but these products are they use powerful CPUs or MCUs embedded. They can run a lot of things, so they are more vulnerable to security attacks. In my opinion, I might be a little bit odd in saying this, but in my opinion, more performance potentially means more security, not less. Okay. If you have more performance, you can do a lot more to make your application secure. Okay. Exactly. So now these things, like a stupid I/O module, if I can say stupid, has a 4-core 1 gigahertz plus CPU with gigabytes of memory and stuff like that. You can do a lot of things on that, and if you spend some part of your attention, of your development effort into using this power to make the product secure, you will succeed. There are a lot of I/O modules that, for example, are networked with Ethernet, and they use like very simple dedicated chips to do the networking, and these chips cannot even do a basic encryption, so HTTPS, SSL, and stuff like that. They cannot do that because they don't have the power to do that. So that is less security, not more. And with this, basically, you have an I/O module with the same, let's say, security capability of a data center server in a rack. Same thing, absolutely same thing. This is, exactly. I think, pretty important.
Yeah, no, I totally agree. And like you say, I think one of the things that often gets forgotten in the development of software applications is security. It's left until the last moment. And like you say, if you've got a very powerful processor, even if you end up not considering it until the last moment, which you obviously shouldn't do, you're going to have the processor performance left over that's needed to fulfill and execute those security sections of the code, which is going to be important.
And you can of course take advantage, leverage all the work in the security area that is being done by tons of people on these platforms, on Linux, on Raspberry Pi, etc.
Yeah, no, exactly. And that's another really critical thing, isn't it? So security is not achieved by obscurity. You really do need to follow these open standards, which have been peer checked by lots of people. A lot of clever people who understand a lot about mathematics, much more than I do, have proven that these algorithms will take a very, very long time to break. And if they're implemented properly, that's the other problem, isn't it? It's not just the algorithms like AES and DES and the elliptic encryption. It's also the way you implement it in the hardware. If you implement it incorrectly, then obviously you can work around it. So that needs to be considered as well.
Yeah.
Super.
Absolutely. Yeah.
So industrial engineers, if somebody was coming from that side of the development process, they typically use these structured programming tools for PLCs. But obviously, if with your products based upon Raspberry Pi and Arduino, the programming environments require programming languages, typically sort of C++ for Arduino. Python is very popular on Raspberry Pi. So how do your customers choose to program the Strato and the Iono products?
Yeah. First of all, they choose to develop the way they like.
Okay.
One thing we say whenever we launch a new product, we always say this is a new product that you already know how to use.
Right.
Reason for that is that if this product is based on, again, a Raspberry Pi, you already know how to use the Raspberry Pi. You develop on that Raspberry Pi with the language of your choice, not of my choice. The Raspberry Pi particularly has basically all the freedom of Linux in general. You can choose anything from Python, as you said, to C++, to Java, to anything else. And as I remember, as we are on Elektor TV, there is a book from Elektor that's I don't remember exactly the title, but it's something like PLC programming.
That's correct. Yeah.
Raspberry Pi and OpenPLC, something like that.
Yeah.
And that book basically deals with how to use the standard way of programming PLCs, which is basically ladder logic, ladder programming, or basically which is defined in a specific standard that is that's I think IEC 61131-3, something like that. That basically is basically the definition of how you program a PLC. And of course, a Raspberry Pi core and some of the Arduino products have all they need in terms of hardware to be able to implement this kind of software stack. So if you want to develop with that, you can do that. There are projects, open or closed. There is like Codesys, for example, which is a specific solution that implements this kind of programming logic on the Raspberry Pi that runs, of course, on our products. There is, again, OpenPLC that you can use. And in order to do that, we don't have to do anything. Again, you go buy the Elektor book that I was saying, read it. It deals about how to use OpenPLC on a Raspberry Pi, and you can directly use that over here. So you can choose. It really depends where you're coming from with your background, where the company where you're working, the project where you're working coming from. Of course, if you are migrating tons of software written in ladder, you may want to use one of these tools. If your background is in programming in Java, you might prefer to develop your stuff in Java rather than other things. So it really depends. And the important thing is that here you have, let's say, I think, widest possible freedom of choice.
Super. Well, that's fantastic. I think it's a fascinating area, and I'm really interested and excited to see how it develops further. We're moving on time-wise a little bit, so I'm going to move on now and say thank you very much for your input here. I've got a few more questions that I think you'll have some answers to later on in the show, and sure, we can also pose to our other guests as well to see what their experiences have been. So thanks very much, and I'm going to move on now to Fabio. Just bring Fabio in here. Hi, Fabio. Welcome back.
Hi again.
So you're working for Mendai.io, and as we were discussing at the beginning, it's a software and firmware solution for keeping IoT type endpoints firmware up to date. What's your role at Mendai.io?
In Mendai, I'm the product manager and the CTO, or lead architect, if you prefer. So I oversee the roadmap and the technical implementation, the architecture of the product.
Yeah. So I think everybody who's watching, who's involved in IoT or industrial IoT or Industry 4.0, whatever you want to call it, will understand that keeping the firmware up to date on all of these IoT devices is difficult. From the perspective of Mender.io, why is it so complicated? Why is it so difficult?
Thank you for the question. It's extremely interesting because updating the software on embedded devices in the field is way more complicated than keeping servers up to date in the cloud. You have to take into account several limitations like connectivity. Sometimes you have 3G, 4G, or satellite connections. You have limitations in the bandwidth. You have hardware limitations, so storage on your device or computing resources you have available on the hardware. And of course, you cannot accept compromises when it comes to security. So the device can, for example, run in networks that you don't trust, so untrusted network or segregated network. You don't have connectivity to internet. And to make things even more complicated, you don't have access to the devices. So if something goes wrong, for example, in the middle of the update, you lose power and the device just shut down in the middle of an update, then you can break the device. So all these limitations make updating the devices in the field quite complicated.
No, exactly, and I think bricking the device, as it's termed, I don't know where the word comes from, but probably because the unit itself is about as useful as a brick at the point where you're not able to access it anymore. That's really the problem, isn't it? We've got maybe IoT sensors in, let's say, in a city measuring air quality. They could all require somebody to physically go to them and work on them. But then we have other IoT applications where we have sensors spread around in fields, across farmland, in deserts. It's not really possible to just drop out there and replace them and program them by hand. Now, the term embedded obviously covers a lot of different types of solutions, everything from bare metal to bare metal operating systems or microcontrollers to embedded Linux on things like Raspberry Pi. Where does Mender's solution fit in? Do you support all of those things, or have you focused on one particular type of application?
I would like to share one slide if it is possible, so we can have Thank you very much. This one is a good one. So Mender is an end-to-end solution. It means that it's a composition of a management server and a Mender client you can run on your device. The Mender client is consuming a set of APIs that we expose from the management server. Now, the Mender client running on the device is responsible for performing the updates based on the instructions that it's receiving from the Mender server. The Mender client, the official Mender client we support, is targeted to Linux devices. And we provide several tools and ready-to-use recipes to update the devices running Linux. However, we have users and customers who implemented a minimal set of features in custom clients running on other type of devices, ranging from microcontrollers to RTOS devices. So it's possible to use the Mender capabilities and the orchestration from the Mender server with devices not running Linux. However, the main Mender client and the focus of our product is on the devices running Linux.
Right. And so are there any sort of limitations on the device, or is it just a case of installing your Mender client onto a Linux-based platform?
Yes, the Mender client depends on the capabilities from the Linux kernel. So the way it works, it integrates with the bootloader, and it provides both full system updates and application updates. When you perform a full system update, the Mender client will write the new firmware, the new operating system, into inactive partition. In this case, in the diagram, you have two partitions, one violet and one blue, and the Mender client will write the new version of the software into another partition and then update the bootloader. There is a deep integration with the bootloader and reboot the device into the new version. Of course, this A-B partitioning is designed in a way that the Mender client is capable of rolling back if something goes wrong. So if the device doesn't boot or it has issues, doesn't connect to the network, or one of the self-verification steps you inject into the update process fail, then the Mender client will roll back and go to the previous version. In this way, the risk of breaking the device is way lower. Of course, this deep integration with the operating system depends on the presence of Linux. But as I mentioned before, with different set of devices and with different requirements, it's possible to write custom clients consuming the device APIs provided by the management server and then use Mender in other contexts.
So another question, when we're approaching any type of firmware update in the field or an over-the-air update, is it necessary to then for the memory, say the flash storage for these devices, do I have to have twice the amount of flash storage as I'd planned to have when using this, so as I've got the space that's needed in order to have this second copy or this backup version?
Mender is extremely flexible, so it really depends on your specific use case. Let's say that the happy path, the usual way, is using an A/B partitioning layout, which means that you have two independent partitions where you can store the operating system. So if you have an SD card, you have to reserve some space for the A partition, some space for the B. There is no need to have free space to store the firmware as you get the updates, because the Mender client will receive it from the server and automatically write it to the inactive partition without buffering it on the local space. However, this is the preferred way. You can configure the Mender client and adapt it to different use cases, and there is no need to perform A/B updates. So depending on your specific requirements, the layout you have on your device, you can adapt the Mender client. One thing which I think is worth mentioning is that Mender client is extremely flexible. So it doesn't dictate any particular setup on the device, and it's possible to customize all the steps, all the process, both for full system updates and application updates. The Mender client was designed initially to perform full system updates, but is now capable of installing any kind of update, and you can extend the functionalities of the Mender client, providing update modules, so custom extensions on top of the core capabilities, and perform container updates, file updates, or updating any kind of software running on your device.
Now, there's lots of different versions of embedded Linux that are used on the market. Do you have any preferences or ones that are supported straight out of the box?
We have a few platforms that we support out of the box. So if you're using the Octo, for example, to build the firmware for your device, we provide ready-to-use meta layers. You just include the official Mender meta layer, and you can install the Mender client and then adapt it or configure it. The same is true for Boot. If you're using binary distributions like Debian and Ubuntu, we provide ready-to-use binary packages you can install. Otherwise, you can simply compile the Mender client and install it manually in your system. So it's extremely flexible when it comes to integration with your operating system. Of course, when it comes to onboarding, so giving it a try, we suggest using Raspberry Pi because it's so easy, and it takes like less than 10 minutes to have a Mender-enabled Raspberry Pi. Super.
Now, the other part of this solution, of course, is the server. What does the user or the team that's managing all these IoT endpoints see when they log into the server, and how does that update process look? Does it just point and click and everything updates, or do you recommend doing it in batches to make sure that really you don't break everything if there is a problem?
The backend, so the management server, is a composition of microservices. You can download and install it on a virtual machine, or a single virtual machine running on Docker Compose, or you can scale it up. We suggest Kubernetes. So the same set of services can manage a few devices up to millions of devices. It just scales linearly. When it comes to the management of the device, all the operations can be performed through a UI, an easy-to-use point-and-click UI, or through a comprehensive set of APIs. So it's possible to use Mender directly as a user or integrate it with other systems. So doing a server-to-server integration. In this case, you control the update process using the APIs. Mender, both the client and the management server, are open source projects, so you can just download and install them and run them. However, for the Mender server, we provide an enterprise version with extended functionalities and capabilities when it comes to more complex scenarios. So, for example, phase rollouts or scheduled deployments, or customizing the way the update process is working, orchestrating the update of multiple devices in one single system. So you want to control that all the devices composing a system are updated at the same time and they reboot at the same time. Then these features are available as part of Mender Enterprise.
Now, obviously, keeping software up to date is a challenge for any organization. I guess Mender gets used in all types of industries, or do you see customers from specific industries coming to you, say industrial or automotive, or maybe even so consumer applications? Is there any one space that's really taking this seriously and coming to you with specific problems?
This is a very interesting question. So we have customers in many different industries, ranging from energy to transportation, automotive, industrial, medical devices, even consumer devices. But the challenges in the various sectors are similar, despite there is a heterogeneous set of use cases. Each scenario is different, and some of the features are more relevant in some contexts than others. It's easy to imagine because updating software running on our warships through a satellite connection in the middle of the ocean is totally different than updating the software on a gas boiler in a residential house. So the requirements are different, but at the end, the core features are the same, and the need of updating the software is always there, because it's one of the main concerns when it comes to security, the ability to remotely update the software and fix security issues you have on your device. So what changes is the set of features that you need, but the core requirements are the same.
Mm-hmm. And in terms of security, obviously that's a very important part of this. Is there enough security in most Linux applications, or is one of these encryption devices required in the hardware in order to provide that the trusted the TPM, the trusted point where all of the keys are stored and things like that?
When it comes to Mender, it's possible to use it without any hardware security module, so any TPM. If it's available on the device, then of course the Mender client can take advantage of it, both for establishing the trust channel between the device and the backend, as well as performing encryption or verification of signatures. As we see, more and more customers are implementing hardware security on the devices, and of course, this makes their devices more secure, and taking advantage of the hardware, it's a plus. But this is not strictly required, and there are ways to enforce the right security, also when performing updates, even without the need of a hardware security module. So again, it depends on the type of board, the hardware, and the specific use case.
Now, in 2 weeks' time, Embedded World opens its doors in Nuremberg in Germany. Will Mender.io be there?
Yes, of course. We will have a booth there, and my colleagues, I won't be there, but my colleagues will be there if you have any questions regarding security, OTA, and we will have a cool demo there, they're telling me.
Super. Now, I'm really excited because I've read about this for a long time. I wrote about it a little while back, and I also spoke to Eystein, your colleague, who's also in the team. So I will definitely be dropping by in Hall 4 to booth number 545 to go and visit the guys from Mender.io and find out a little bit more about what's going on and see the solution in action. So what I'm going to do now is just pull everybody back in. Welcome back, everybody. Thank you for the great information that you've been sharing. What I wanted to do was just have a quick chat about some other things that have cropped up in the meantime. So, for example, Ulde, I think we were talking about the chip crisis. You mentioned that as you were talking. Tell us a little bit about how the chip crisis has impacted you.
Well, let's say our impact has been, let's say, limited in terms of, let's say, the ability to deliver our products. But the huge impact is the fact that we had to really change the way we used to work in terms of components acquisition. Like up to 1 year ago, 1 year and a half ago, you basically the procurement of all components was pretty straightforward. You needed to manufacture something, you acquire the components like a few weeks, let's say couple of months before, no more than that. Now this 1 or 2 months has been, let's say, expanded by, let's say, 10-fold, 20-fold, something like that. So we now have to have the supply of components like 1 year or more in advance. The other thing is the impact on the development of new products, which is even worse. And honestly, my concern in this area is not so much, let's say, for us. We're already relatively sized so to be able to handle that. But my real deep concern and my heart, in a sense, is with like the smaller companies, startups, or that maybe people who have like a great idea and they want to build something. Now, even if you want to buy an Arduino board or a Raspberry Pi, you may run into troubles. Not
Exactly,
being able
yeah.
to readily find the board to play something. Okay,
Yeah.
for your hobby. Okay, so that's a huge part, and it's I mean, in a sense, it's let's say understated. We're all concerned with BMW not being able to deliver, let's say, a part of the multimedia system in a car. Or something like that. But to me, again, my heart goes to where, let's say, like the low level innovation is. That would be a long time. Anyways.
Yeah, no, I totally with you there. I totally understand. I follow a lot of small developers on Twitter, and it's really heartbreaking when they share their delivery times that they find sort of 40 weeks, 50 weeks for standard parts, and it's very upsetting. Yeah. Fabio, obviously you're with Mender more of a software solution, but are your customers also struggling with chip supply, and is that making them sort of change the way that they're implementing some of their products, or changing the way that they're rolling out?
Yes, definitely. So what Ulderico says just resonates very well. Our customers are facing the same issues. This, of course, is causing delays all across the chain. As you can imagine, we're a software solution, so we come quite late in the chain of development. Hardware is becoming a bottleneck, yes.
And Barath, I mean, you're sitting there in automotive, and Ulderico already said about BMW not being able to bring new vehicles to market. I mean, you must also be seeing the same thing. What are automotive suppliers and the automotive supply chain doing at the moment with sort of limited chip supply?
So what from my knowledge, yes, so there is a lot of shortage. But what we are trying to do in this shortage is, to focus on the next generation of Infineon Oryx. So there is Infineon 4X, and so our focus is mainly on that, and to bring out, like a safety certified and cybersecurity certified compiler, optimized compiler, basically, to have something ready for the future.
Super. So it's good to hear that, there is some good news amongst the bad there. I understand, I think it was Eben Upton was saying that he's been working very hard through their supply chain, their official supply chains, to make sure that companies like Ulderico's, who are already customers, are actually getting parts if they've placed orders. So it's good to hear all of that. Well, we're rapidly running out of time. I'd like to thank each and every one of you for joining us. It's been a really exciting and interesting discussion. And I'm looking forward to seeing those of you who will be attending Embedded World in person. And if you're not there, of course, then hopefully we'll get to meet up in person some other time. So thanks ever so much to all three of you.
Thank you very much.
Thank you very much. Thanks.
Thank you very much.
You're welcome. So I'm just going to take you out of the feed here and wrap up the show for today. So there we have it. So it's clear that in the world of embedded systems and IoT, there is no end to creativity, with solutions to tackle each problem in every industry. My thanks to today's experts, Barath Koppa from Tasking, Ulderico Arciadiaco, Ulderico Arciadiaco from Sfera Labs, and Fabio Tranchitella from Mender.io. You've delivered some brilliant insights for us today, so thank you, thank you, thank you. Now, if you're planning to visit Embedded World in person this month, don't forget to drop by the Elektor stand in Hall 4A, booth number 646. We're close to where analog devices, Murata and DigiKey can be found. And don't worry if you can't attend, because the Elektor team will be there every day collecting video interviews to share on our YouTube channel, Elektor TV. Furthermore, my colleagues Jens and Matthias will be providing their wrap-up of the trade fair in their show Elektor Lab Talk on the 30th of June. So that wraps it up for today. Please like, subscribe and share wherever you are watching, or drop by the website at elektormagazine.com/Elektor Engineering Insights to see the topics for future shows. And if you'd like to join me as a guest, write me an email, drop me a tweet, or reach out to me, Stuart Cording, on LinkedIn. Thanks for joining, stay in touch, and don't forget to keep asking your engineering questions.